In this video, I'd like to remind you first of what we did in a previous video where we talked about a mole is A. And the first thing that we discussed was that a mole is a number. And that number is always the same. Just like if we were talking about a pair is a number, well, a pair is equal to 2. A dozen is a number, while a dozen equals 12. A mole is a number. A mole is equal to this number. Now, typically, when we're dealing with this number, we're dealing with particles, such as atoms, if they're individual atoms, molecules, if two atoms are stuck together that are both nonmetals, or formula units if two atoms are stuck together and one is a metal and the other is a nonmetal. We call them formula units. So the only difference between molecules and formula units is what kind of atoms are stuck together. If it's two nonmetals, we call them molecules. If it's a metal and a nonmetal, we call them formula units. If they're individual atoms, we just call them atoms. But it's just, a mole is just simply a number. We then developed this idea that a mole is also a mass. And we use the term molar mass, the mass of a mole. That's how we define molar mass. It's just simply the mass of a mole. Well, where does that mass come from? Well, it's a little bit trickier because when we talk about a number, it's always this number. It never changes. But when we talk about a mass, it does change because we have to go look at the atomic weight on the periodic table to see what that mass is going to be equal to. And whatever that mass is, we call that the molar mass. We learned how to deal with the molar mass if you're dealing with an atom, just looking at the periodic table. We also looked at how you deal with the molar mass if you're dealing with a molecule or a formula unit and adding up each individual one depending on how many of each type of atom there are. In this video, we're going to look at the final piece, and the final interpretation of a mole is the volume. So here, the final piece is going to be volume, and we're going to be looking at what is called the molar volume. And the molar volume, as you might expect, is just simply the volume of 1 mole of gas. It has to be a gas. This only works if you're dealing with a gas. So there are some stipulations, there are some rules on whether we can use this third piece. When you're dealing with a mole as a number, there's no restrictions. It's always this number. When you're dealing with a molar mass, there's no restrictions. It's always that mass from the periodic table. When you're dealing with the volume, there are some restrictions. It's the volume of 1 mole of gas. Now, what are the restrictions? When I look at my article, it looks like it's a gas at what they call STP. STP stands for standard temperature and pressure. So volume of 1 mole of gas at STP. And we're going to define STP here. STP stands for standard temperature and pressure. Standard temperature is identified as what it states in the article at 0 degrees Celsius. Standard temperature is 0 degrees Celsius, and standard pressure is 1 atmosphere. If you're dealing with a gas, remember it has to be a gas, and you're at standard temperature and pressure, the molar volume is this: 1 mole of your gas is equal to 22.4 liters, as long as you are at this temperature and this pressure. So 1 mole of gas, that is the molar volume. 1 mole of gas is 22.4 liters as long as you are at standard temperature and pressure. So I want to point something out. The first off is when a mole is stated as a number, that number never changes. But when you're dealing with a mass, that number changes based off the periodic table and looking at the atomic weight. But when you're looking at molar volume, that number does not change either as long as you're at STP. So for instance, if we found a gas such as argon, argon is a gas, we could write down 1 mole of argon is equal to 22.4 liters of argon. I don't have to look it up. I know that it is 22.4 liters as long as our temperature is 0 degrees Celsius and our pressure is 1 atmosphere. What about if we were dealing with oxygen molecules? So 1 mole of O2 is equal to 22.4 liters of O2 at STP. As long as you are a gas, any gas, at STP, we know we're going to be at 22.4 liters. How about 1 mole of carbon dioxide? 1 mole of carbon dioxide, even though it is a molecule, even though it's got 1 carbon and 2 oxygen, it is going to be 22.4 liters of CO2 as long as you are at standard temperature and standard pressure. So a mole is a number, it's also a mass, and it's also a volume. I like that this article that we had a chance to annotate goes through that. One interpretation, a specific number. What is that specific number? 6.02 e to the 23rd particles. It's also a specific mass. Where does that mass come from? It comes from the periodic table. And then it's also a specific volume, and that volume is 22.4 liters. Now you'll notice they go to the round to the nearest hundredth. We only rounded to the nearest tenth, which is what we will be dealing with in our class. I hope this helps in understanding the concept of a mole, and that a mole is a number, a mole is a mass, and a mole is a volume.